you. Thank you very much, Sven. Arcis have developed and patented a protocol that simplifies and speeds up the delivery of nucleic acids for diagnostic testing. This is an area that's been completely neglected for many, many years. There's been a huge amount of development on the diagnostic equipment, the diagnostic testing, so sensitivity has been improved, throughput has been improved, the machines have been made much bigger so we can put many more tests through, and they've also been made much smaller so that we can actually do these at point of care. But nothing has really been done with that front end on how we actually prepare that nucleic acid for that diagnostic test. So Arcis Biotechnology have developed this protocol. It's a very simple protocol, requires just 2 simple steps. We are an ISO 13485 accredited company, which means we're registered for the manufacture of in vitro diagnostic medical devices. In the last 12 months, we have launched 3 products to the market, and we're gaining commercial traction with these products. We've got a licensing agreement in place, and we're quite far down the road with a second opportunity, and we've also got distributor agreements in place. We are based at SciTech Daresbury, which is in the northwest, where we have state-of-the-art laboratories and offices, and we currently have 10 full-time employees. So what is it that we do? Well, our protocol is very simple. We've got 2 tubes. The first tube is the lysing material. So that's the first tube is the material that accesses that nucleic acid, the DNA and the RNA. And in doing so, the interaction of that material with our chemical causes the DNA or the nucleic acid to coil up. And it coils up, and once it's coiled, it's protected. So it can't actually be degraded by any of the other material within that sample. And that's quite unique. That's how we're very different to everybody else. A lot of other companies have to take out the nucleic acid out of that matrix, but we can actually protect it within that matrix, which is why we can have that simplified protocol. You can actually take a lot of different materials, so you can take a buccal swab, a nasal swab, it can be blood, it could be urine. It could also be a non-clinical application, so you could take a leaf, part of a root, a bit of soil for looking for plant pathogens. You could take food. We've looked at mouse's ear, we've looked at mouse's tail, etc. So it's actually a unique solution. Once you've got it in tube 1, we can hold it there, and we can hold it there for a long period of time, and it's preserved. That material is preserved to the point that you want to test it. So you could actually ship it, you could walk it, you could store it. When you're ready to do that test, you take the pipette, which is the only other bit of equipment that you need. You take the pipette, take it from sample 1 into sample 2, and in doing so, you relax that structure. So you take it from its coiled state into an elongated state, and then you can look for the bit of genetic material and amplify that for the diagnostic test. So we've got a rapid preparation for pathogen testing, which is an infectious disease testing, such as malaria, Zika, Ebola, also healthcare-acquired infections, MRSA, and other infectious diseases. But also, we can look for cancer biomarkers. And why are they important, or how do we do that? So with the DNA, that's a double-stranded, coiled, you'll see the structure, it's double-stranded. But the RNA is far more sensitive. It's a single strand of DNA, which means it's eminently more degradable. So it degrades far easier than the DNA. So by preserving this is actually quite critical. But also, the RNA is indicative of your real state. So if you have an infection and it's multiplying, then the RNA is proliferating in far greater numbers than the DNA, up to 10 times more RNA than there is DNA. So if we can actually capture that, we can then go into early diagnostic testing and faster diagnostic testing. And so this is important for looking at screening testing. At the moment, for example, for a prostate cancer, if you had a prostate cancer and that was growing, then bits of that cancer will be shedding off into your urine. So if you could capture that in the urine, then you've got a screening technology. At the moment, what happens is, for another reason, you would probably go, blokes over 50 would probably go to their GP. The first thing that the GP would do is a digital rectum examination, which most blokes don't really appreciate. But also, they will then do a PSA test, and at best, that PSA test is 50% accurate. So if you could take a sample at home, so there's no concerns, the gentlemen are quite comfortable with that, walk that to your GP and do the testing there, that RNA biomarker is preserved so you can actually do that testing. So we're enabling early stage testing. We've got a very, very strong team behind us. Paul Folger is our non-executive chairman. Pete Whitehurst is our CEO, and I've obviously introduced myself. But in summary, what we've got then is a very simple method of accessing nucleic acid. The ability to preserve that material so that we can actually ship it to various places, or the sample preparation can be done at home. And that's then leading to enabling screening of cancer testing. So that will lead to earlier diagnostics, faster treatment, and better outcomes, which is great for us all. Thank you very much. I appreciate your time.